So here, if you look at the diagrams here, let us try to observe what is happening in the. We are already saying that the cathode rays are nothing but sources of electrons, and the anode rays are the sources of the protons. So let us try to differentiate with the diagrammatic view. With the help of a diagram, let us try to understand how the cathode rays. If you take cathode rays, you know very well that cathode rays are nothing but stream of negatively charged particles called electrons. So what is happening here is, this is the discharge tube. You can see that the diagram, you can see this diagram is the discharge tube. It is made up of a long cylindrical glass tube, discharge tube. The discharge tube, you find one end of the discharge tube is equipped with the cathode electrode. You can see this is cathode electrode, and this is the conducting wire, and this is the concave surface of the that is anode electrode, which is given by the positive sign convention. Anode electrode given by the positive sign convention, and negative sign is given for the cathode as a sign convention. Then you find that once the current is going to pass into the discharge tube, of course we are filling the certain source of gas, certain lighter gas is going to be filled inside this discharge tube, maintaining a low pressure, because if you increase the pressure, the discharge tube may break. That's why we have to use low pressure, the gas at low pressure, but of course the voltage is high voltage. The potential difference applied during the passing of current into the discharge tube is we pass very high voltage, not less than 10,000 volts, but pressure is just for almost 5 to 10 atmospheres, not more than that. So once the current is going to enter into the discharge tube, you find that from the cathode electrode, you find that stream of particles keep scintillating, keep moving from the cathode electrode to the anode electrode, and they hit on the surface of the electrode, that is anode surface. Once they hit, you find that this stream of cathode rays can be traced by the photographic plate. Maybe this is the kind of photographic plate which is acting on the photographic plate. You are trying to trap the cathode rays. But one thing what you have to understand here is, the electrons in the form of negatively charged particles, they are originating from the cathode electrode. And one more important aspect in the cathode rays is, it is independent of the cathode rays. Cathode rays obtained, formation of cathode rays are independent of nature of gases. Nature of gases used in discharge tube. Used in discharged tube. So we can see that all the negatively charged particles, stream of negatively charged particles, they are trying to originate from the cathode electrode, and they are trapped on the photographic plate. If you try to put a small mechanical wheel, because cathode rays have certain high energy, they have high kinetic energy, they have higher kinetic energy, and they also have the higher velocity. Based on this, you can see that they cause mechanical motion when any object is placed in their origin of the beam or particular row of the cathode rays. So this is how we can originate the cathode rays from the cathode electrode. Now if you look into the anode rays, the only difference between cathode rays and anode rays is, formation of anode rays are dependent. They are dependent on nature of gas used. They are dependent on the nature of gas used in discharge tube. And because we are saying that it is dependent on the nature of the gas which is used in the discharge tube, what is happening is, suppose you are trying to fill some gas inside the discharge tube, some rarefied gas, for example helium gas or hydrogen gas, if you are going to use in the discharge tube. Then for example, if you are using hydrogen gas, the hydrogen gas first, once you are going to pass the electric current, once you are passing the electric current at high voltage into the discharge tube, you find that the gases which are present, they get ionized. If it is ionized, it gives a charged particle. And also free electrons. Along with that, it also gives free electrons. So what is happening is, suppose if I am writing here one equation I am writing, if you take H2 gas, when it is getting ionized, it becomes hydrogen atom. It is in the atomic state. 2 hydrogen atoms we are getting. When you are getting 2 hydrogen atoms, still the current is going to pass. It absorbs some amount of current from the discharge tube, from the source of current, and these atoms, they get ionized to become H plus ions and free electrons. These free electrons, you can see all these are nothing but the electrons. The arrows which are moving towards the anode are electrons, because electrons are negatively charged particles, and the arrows which are moving towards the cathode, these are all anode rays. Means here H plus ions, all H plus ions, we can call them as positive rays. These H plus ions are nothing but protons, and we can call them as positive rays. We can call them as positive rays, and these positive rays, obviously whatever the ions are formed because of the ionization of the atoms, molecules are broken into atoms, and atoms are ionized to positively charged particles. Positively charged particles are going to become the positive rays. These positive rays, they migrate towards the cathode electrode. You can see that this cathode is perforated. So when this cathode is perforated, you can see from the gaps all the canal rays or the positive rays are moving towards the cathode, and they move beyond the cathode. They are moving beyond the cathode because maybe here we are trying to place a photographic plate. Here we are trying to place a photographic plate. In the photographic plate, we are going to trace all the positive rays obtained during that is production of anode rays using the discharge tube. So what is happening here is all the positively charged particles, that is ionized gases, they move towards the cathode electrode, and all the free electrons which are obtained during the ionization of the atoms, that is hydrogen gas atoms, all the free electrons which are obtained, they try to move towards the cathode electrode, because the simple reason is electrons are negatively charged particles. All the electrons are negatively charged particles, but the anode electrode is positive, so they try to migrate towards the oppositely charged electrodes. They try to migrate towards the oppositely charged electrodes such that the positive particles, that is anode rays, are separately collected at the photographic plate within the discharge tube. So from these two diagrams, it is very clear and very systematically we are able to differentiate the production of anode rays as well as cathode rays.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.